So good morning, guys. Obviously, I'm not there. I'm out for an all-day meeting. So I am going to ask you to get into your groups to do a homework check. It's 10 points for doing, 5 points for checking, and if the key wasn't online, then you should have checked with the book key. So if you could do that now, please ask the substitute for your homework sheets, your grading sheets, and then also can anyone please come up to the board right now and pause the video so that it doesn't go into the lesson. Again, right now, please anyone come up to the board and please pause the video. Alright, so otherwise, at this point you should have done your homework check. It was for homework number 9, and it was a total of 15 points, 10 points for doing, 5 points for checking. I am going to do your 5.4 day 2 notes today, and then at the end of the video, I am going to go through a free response question that you had for homework yesterday, I believe. Oh, not yesterday, so that would have been Thursday. And I will do the entire problem in case, as much as you see the answer key, it may still be confusing, and we haven't had as much time to go over a lot of the free response questions. So here we go. If you guys could turn to your 5.4 day 2 notes. The notes are actually really short, and today, again, is another easy lesson that is repetitive, meaning we've done it before, and now you're just going into a little bit more depth. So 5.4 day 2 looks like this, and the first set of notes you'll see, notes that we've definitely taken already. So, little reminder how to do it, and then I think I have right underneath here just a random free response question that kind of use the topic, but I am going to squeeze in one example problem from your homework. Okay? So let's start off with finding total area algebraically, meaning you don't have a graphing calculator. So if you want to find total area, which is very helpful to find things like total distance traveled. To find the total area, you would first find the x-intercepts of whatever function you're trying to find the total area of. Second step, you're going to do a sign chart for that same function. And then last step, remember this is the kind of weird step that we talk about, you are going to add positive integrals and subtract negative integrals. Alright, so that should be a review of what we've done before, and then I did say to you guys that I do want you to be able to do it by hand, meaning algebraically, and then also by calculator. So remember, if you're going to do the total area by calculator, you do fn int absolute value of the function, comma x, comma a, where you're starting the area to where you end the area. And then if you have the newer calculators, which are a little bit nicer, you would have a here, b here. Inside of this box, you would put the absolute value of y1, and then dx. So underneath there, I think there's a free response question, but I am going to do one of your homework problems. So it gives you the graph, which is kind of nice, but I wanted to show you, because it's using two different functions, how you would set this up. So right now, you may want to take out a sheet of paper for where you would be doing your homework. And this is number 46. I think you guys are assigned 41 to 52. You're going to do it by hand first, and then you're going to write out the notation by calculator to double check your answer. So for 46 here, we haven't done one where there's been two equations, but what I want you to do is break it up wherever the equation stops. So if you look at 1, 1, the equation actually stops for root of x, and then after 1, 1, the equation becomes x squared. So your total area, in this case, would be two integrals. So the first integral, which is a positive integral, from 0 to 1, of the function root of x, dx. And then the second integral is a positive integral, and the second one is this piece here. And again, we're going from 1 until 2, and that's of the function x squared. So I just wanted to make sure that you knew how to do a problem if there's more than one function. So just to finish this problem off, first thing I would do is remember that this is x to the 1/2. So the antiderivative would be 1/2 plus 1 would be 3/2. Dividing by 3/2 is the same thing as multiplying by 2/3. F of 1 would be 2/3. F of 0 would be 0. And so for this problem, we end up that the area is 2/3. All right, in blue, I'm going to do this side in orange then. My antiderivative would be add 1 to the power, divide by that power. Same thing as 1/3 x cubed. F of 2 would be 8/3. F of 1 would be 1/3. So for this value, you end up with 8/3 minus 1/3. So I believe we end up with 2/3 plus 7/3, which equals 9/3. So my final answer for the total area of that would be 3. All right, so that is essentially what I want you to do for your algebraically, and then I want you to show what would you have typed in the calculator to get your answer. So for this guy, I would have put inside of function y1 the root of x. In function y2, I would have put x squared, and then I would have done fn int of the absolute value of root of x, comma x, comma 0, comma 1, plus fn int of the absolute value of x squared, comma x, comma 1, comma 2. Now, in this case, the absolute value is doing absolutely nothing, meaning the integral from 0 to 1 of root of x is exactly the same as the integral from 0 to 1 of the absolute value of root of x, because the area is positive. So I'm still using that notation for absolute value because I want you to remember that total area, you use the absolute value when you do it in the calculator, but for just net signed area, you do the regular integral without the absolute value. All right, last thing for today is the free response problem that's underneath the notes that you were just taking. So if you go back into your packets, 2003, Form B. So this is a non-calculator problem, and the reason I know that is because it's after 2002, and it's question number 4. So questions 1, 2, and 3 are always calculator problems, and then 4, 5, and 6 are usually non-calculator problems. All right, so let's start off with find the acceleration of the particle. All right, so part A. Find the acceleration of the particle. Now, to be honest, I have a feeling we've actually done this problem or something very similar. If the whole class remembers doing this exact problem, you can fast forward to the other free response question that I'm going to go over, which was from last night's homework. But honestly, I can't remember right now. I know we've done it. I just don't know if we've done it recently. So I would like to go back through it because it reviews derivatives and reviews kind of integrals. But if you know for a fact we've done it recently, you're more than welcome to, as a class, make the vote to fast forward. All right, so part A, acceleration of the particle at time equal to 3. So literally, I would do this and write the answer. So the answer would be, let's see, I already put the function into y equals. I just want to show you that. And then I want to do that the acceleration at 3 is the same as the velocity's derivative at 3. So I would just do math. N deriv is number 8. So this would be an x. This would be vars, move over to function, y1. And then, did I press it? And then move over. And I want this at 3. So the answer is negative 0.135. Negative 0.135. Letter B. Asks, is the speed of the particle increasing at time equal to 3? Well, I already know that the acceleration is negative, so now all I need is the velocity at 3. And so same thing, I'm going to go in here, vars, move over to y vars, press enter, I think. All right, and then we're going to do it at 3. So this will evaluate the function that I put into y1, which was the velocity function. So this is really giving me the velocity at 3. And that value is negative 0.864. Negative 0.864. The next value was a 6, so you could put negative 0.865 and it would be correct. Now, the function is therefore speeding up because v of t and a of t are both negative. They're the same sign, then we speed up. If they're opposite signs, then we slow down. Part C, find all the values for t at which the function changes direction. And I believe in this case we're just looking at time greater than 0. So I'm going to come back and I want to check for changing direction. So let me actually write down my definition. Changing direction means that I have v of t equal to 0 and v of t changes sign. Now, I'm not going to go through the hassle of making a sign chart algebraically. What I'm going to do is graph v of t. So let's go to window. I want my x's to go from 0 to 10. And since I don't know what my y values are going to look like, I'm actually going to look at the table from 0, 1. Okay, so here we go. So if you look at the value at 0, the velocity is 1.7. At 1, the velocity is 0. And after that, it's negative. But the values, are really close to negative 1. So then that tells me that my window, I will try something like y values of negative 2 until positive 2 and see what the graph looks like. That's a pretty good graph. So I'm actually going to copy the graph into my flip chart so that you can see how I do the sign chart using it. All right, so here is my graph for part C. My sign chart would be that since this is v of t and I want v of t sign chart, we're using y values. My sign chart would say that this is at exactly 1. My sign chart then says the y values are positive there and then negative after and 0 right in between. So I know we change direction at t equal to 1. And I already gave my reasons right above. All right, and then letter D. Find the total distance traveled. So total distance traveled, if I'm using the calculator, really quick and easy, I get to do the integral from 0 to 3 of the absolute value of the function that I want, velocity, dt. And then I'm just going to put that straight into the calculator. So I'm going to go to math, number 9. I'm going to go and do from 0, and then up, 3, move over, try to find the absolute value button. I think that's inside of math, under num, there it is. And then y1, which is the velocity function. And then move over and write in my dx. And then press enter. So the total distance that I travel ends up being 1.853. And that right there is a perfect answer. You actually have enough work shown to get all 9 points, even though it looks like there's barely anything here. But it has every little piece that you would need to get all 9 points for this question. All right, so at this point, based on what we've done so far, if you're ready to move into your homework, which was, let me go back, I believe number 9. No, number 10. You may do so. If you would like to see the free response question from last night get done, then you can keep listening. Otherwise, if you graded your free response question and you did very well, then get started on homework number 10. And otherwise, at this point, every single one of you should have something to do. So if you'd like to pay attention now to 2003 Form A question number 4, here we go. So it says, let the function be defined on a closed interval. So things that I know. Oopsie. Closed means I should be thinking of endpoints. I should be thinking of IVT, or maybe Let's see, closed interval. Well, it doesn't really say anything else, continuous, differentiable, anything like that. So I'm just going to start with closed endpoints. All right, f of 0 equals 3. That's important. That's an initial value. How do I know that? Because if you look at the graph, it's the derivative. Therefore, if I want to go back to the function f, I'm going to need an initial value. All right, so the graph of f prime, the derivative of f consists of one line, segment, and a semicircle shown above. Well, I moved it to the right for you. All right, so part A says, and just so you know, this is no calculator. Letter A, on the intervals, where's f increasing? So f increases when f prime is positive. And so if I have the graph of f prime, then right underneath here, from -3 until 4, I can do the f prime sign chart, and I do that using y values. So the y values are 0 at -2, and at +2, the y values are positive between here. They are negative all between -2 to 2, and then they are negative again, so 2 to 4. So f prime is positive from -3 to -2, and the reason is because f prime is greater than 0. That is how you know that f is increasing. Letter B. See how much I can fit on this little page here. Letter B, find the x-coordinate of each point of inflection. So same thing, I'm going to draw an f double prime sign chart from -3 until +4. So f double prime means that I'm going from f prime to f double prime. That's one derivative, which means I should be looking at slopes. So first thing I want to ask, when is the slope 0? That's an easy one. At 2, the slope is 0. And when is it undefined? It's also undefined at 0 because there's a corner. And then I'm going to look at the slopes from -3 to 0. The slopes are negative because it's decreasing. The slope is now positive because it's increasing. And the slope is negative because it's decreasing. All right, so with that, I know that I have points of inflection when f double prime equals 0 and f double prime sign change. And that happens when we get x equal to, now here's the question. Actually, I forgot, undefined here. I got to double check if at x equal to 0, the function is defined. And if you look at the very beginning, let f be a function defined on the closed interval. That means the domain is all real numbers between -3 and 4. What that means is at x equal to 0, the second derivative is undefined, but the function is defined. So I won't go and cross out the value. It means that there is a point. It just happens to be that the second derivative is undefined. So x equal to 0 is a point of inflection, and x equal to 2 is a point of inflection. Letter C, write an equation of the tangent line. So this is going to take a little bit more space. So what I'm going to do is steal these two questions over to the next page. And then I'm going to go back and also steal the graph, which I think thought was separate, but I guess not. All right, so let's take a look. Obviously, that looks funny, but whatever. It will work. There we go. All right, letter C. Find the equation of the tangent line to the graph at point 0, 3. So 0, 3 is the point. Then I need f prime of 0. Well, this is the f prime graph, so f prime of 0 would be the physical y value, and that is -2. So my tangent line equation would be y minus 3 is equal to -2 times x minus 0. And yes, you can leave it that way. Letter D. Find f of -3 and f of 4. So the reason I wanted to do this problem is because I think those two questions are a little bit difficult. Based off of what you've learned so far. So we do know to find f of -3, to go from the derivative back to the function means we're going to do an integral. And we know that we're going to do the integral of the derivative, f. Problem is from where to where. So if you remember, anytime we do an integral, there has to be an initial value. Now, at the very beginning of the problem, we had the value of f of 0 equals 3. So I know that right here, I'm going to have to start with the initial value of f of 0. I'm going to go from 0 until negative 3. And here is what I think is extremely helpful. I and you will always make sure that the smaller limit is at the bottom. So what do I mean by that? I mean that for f of negative 3, we're going to use f of 0, and then we're going to physically swap these two. And the way you do that, you have to now negate the integral. So anytime you want to switch the limits, you switch the sign in front. So if that was a minus from 0 to negative 3, then you would do a plus. Since this is a plus from 0 to negative 3, we're going to turn it into a minus. And that was one of the rules that we learned back in section 5.2. So now I'm going to go look at the graph. I'm going to shade in the net signed area from negative 3 until 0. So negative 3 is here until 0 is here. And here is the net signed area that I'm going to shade in. So what that means is that I will get f of 0 is 3 minus the area in yellow. Oh, sorry, I'm going to actually turn this piece green. So the area in yellow up top is a triangle. The triangle area formula is 1/2 base. The base is 1 wide. How high is it? It is 1 high. All right. And then the other triangle has a negative area because it's underneath the x-axis. So that's where I'm going to get this, let's see, orange minus sign from. And then same thing, I'm just going to do the area of a triangle, 1/2. The base of it is 2 wide. The height of it is 2 high. Now I want to go back to the minus sign that's in front in case you missed the reason why this is here or this is here. We started out with a plus from the original, because remember, to find an ending value, you start with a starting value and add the integral from there to where you're trying to find. The reason why it turned into a minus sign is because the limits went from greater to smaller. So greater to smaller. So what I said to do was always have the smallest at the bottom. Therefore, I switched the integral and made the sign in front negative. So my final answer becomes 3 minus 1/2 minus 2. So I'm going to have to go up this way and give you 3 minus negative 3/2. So obviously, we end up with 6. Am I right to say that that's 6, 7, 8, 9, and the final answer becomes 9/2 if I did my math right. If I didn't, someone mention it, please. All right, so there is f of negative 3. That is a value of 9/2. Now I'm going to do f of 4, and we'll do that by copying just this piece. The graph actually is all I'm going to take over. The next page, and we're doing f of 4, which is still part of letter D. So letter D is kind of long, kind of a pain. So f of 4 would be the same as you need an initial value plus the integral from that value up to where you end. So notice these will be the same, and then these will always be the same when you set up. So let's look at what we get. We want the integral from 0 to 4. The 0 is definitely smaller than 4, so I get to leave the integral alone. I'm going to be doing the net signed area from 0. Remember, go up to the x-axis, to 4, go up to the x-axis. So the area is this sliver. A lot of people think it's a half circle that you find the net signed area of. It is not. It is actually these slivers. So what you should be looking at is the fact that you take the full rectangle and you're going to take away half a circle. That's how you get the area of the pink. So we get f of 0 was 3 plus the integral is going to be a, first of all, let's start with the fact that because the pink area is underneath the x-axis, I know it says a plus, but because of that, I know the area will be negative, and we'll do rectangle minus semicircle. putting it in words just because I'm not there and I can't answer questions if you get confused. So we really do turn into a minus sign. The rectangle has a width of 4 and a height of 2. The semicircle is 1/2 pi. The radius is 2. 2 squared is 4, so that would be the r squared right there. So what do we get? We get 3 minus 8 plus 2 pi. So my final answer becomes -5 plus 2 pi. There you go. So if you had some trouble, which I actually would think that you would have a little bit of trouble with some of these, there are your answers for each of the parts. This will be online so that if you felt like maybe I went a little bit too fast, or if you felt like you missed a piece, you could always find that part of the video and watch it at home by yourselves. There you go. The rest of the time is for you guys to do homework, work together. Make sure if you have questions, you find someone in class to ask it to, and then I will see you all tomorrow. And we're going to hope that I have been recording this whole entire time, because that would be bad if I wasn't. All right.